Assalamualaikum warahmatullahi wabarakatuh. My name is Magat Muhammad Danish bin Magat Zaidi. I'm from final year 2nd Petroleum Geoscience. Today I would like to present my paper review of the topic velocity analysis. My topic for paper review is the automatic velocity analysis using a hybrid regression approach with convolutional neural network by Ferreira et al. Okay, here is the list of my presentation, the table of content which contain 5 content. The first one is the background of study, the second one is the problem statement, and main contents, conclusion, and also the lastly is the recommendation. Firstly, I will start with the background of study of my paper review. So I will explain about the paper. So my topic is regarding the velocity analysis. Uh, for this paper, the method that been used is the hybrid regression approach based on convolutional neural network (CNN) to speed up the velocity analysis workflow. In seismic data analysis, accurate velocity estimation is crucial for various applications such as geophysics, seismic imaging, and exploration. Okay, now we will explore about the different method for velocity analysis and introduce a novel approach that leverage deep learning to automate the process. Actually, a lot of research have been done regarding this topic. As an example that have been mentioned in this paper by Clearbaut. So this researcher used the method of the t² minus x² plane to estimate zero offset and stacking velocities for a reflector. And then there is another approach involved applying various normal move out and move correction to a common midpoint CMP gather and then selecting the best fit velocity for each reflection event. Constant velocity stacks, CVS, another method that been used by a different researcher. And then in CVS, stacking is applied to a seismic line considering a range of constant velocity values, and then the best stack is selected from a panel. Additionally, the computation of the velocity spectrum based on signal coherence is a common method. The interpreter picks the stacking velocities from the velocity spectra by selecting velocities associated with the highest coherence value for each time window, which is then used to correct the gather for NMO. Different with the traditional method have been used for years, recent advancements in machine learning have opened up new possibilities for velocity analysis. Researchers have explored the use of feed-forward neural network (FNN) trained with stimulated annealing semblance computation for improved resolution and optimization method based on genetic algorithm. So the proposed approach for this paper is a hybrid regression approach based on deep learning to automatically pick velocity function. So different with the traditional method with this paper is the traditional is doing it by manually, and for this paper we did through the automatic. Then I will go to the part which is regarding the data sets. So the researcher had done this method in a Western Siberia field, which is a place for a geological to do the seismic acquisition. And then for the setup of this paper, there are 5 pre-stacked data sets with a different characteristic, and the data have been divided by 2 groups. As been mentioned before this, there are 2 data sets, which is there are total of 5 pre-stacked data, and is divided into two. The first dataset is known as dataset A, which they have the characteristic of the good quality and a little noise, and also the CMP gather after deconvolution. While for the second dataset, which is known as the dataset B, it has the average quality and also the CMP gathers before deconvolution. Then now I will go to the next part for my paper review, which is a problem statement. The accurate estimation of velocity is of paramount importance in various fields, including geophysics, seismic imaging, autonomous vehicle, and robotics. And then since this is related to the geophysics, so the focus is on the geophysics. Traditional methods for velocity analysis have been limited by computational complexity and may struggle to handle complex real-world scenarios with a diverse data pattern. Next, I will go to the next part, which is main content. Okay, as shown in the figure, the methodology that been used by the researcher comprises three key steps. The first, we compute the velocity spectrum of a given gather. Next, we estimate the initial velocity function using a curve-fitting approach. Finally, we utilize a convolutional neural network CNN to refine the velocity function based on corrected gather feedback. This approach ensures accuracy and adaptability in velocity analysis. Before diving into the details, let's take a closer look at the initial velocity picking process. We begin by computing the velocity spectrum using coherence measure such as semblance for CMP gather. The semblance metric represents the similarity of reflection events and is crucial for our subsequent steps. For the initial velocity picking, we employ a combination of automatic maxima picking and curve fitting. The method fits a semblance weight splinite to the local maximum point in the velocity spectrum. A Seismic filter is then applied to smooth the final velocity function. Moving on to the CNN training for regression, we leverage the exception architecture, which has demonstrated excellent results in the image classification task. The network is designed to adjust the initial velocity function based on the corrected gather feedback, ensuring optimal local peak and flatness of reflection event. The CNN network is trained using a subset of CMP gathers, and the velocity deviation that improve the initial velocity function are learned. This approach allows for a better adaptation to diverse geological setting and field condition. These are the key points for this paper process. There are four key points. The first one is the velocity spectrum, initial velocity picking, tune velocity picking, and quality control. Next, we move to the result and discussion. As we can see in the result and discussion, which score has more than 70, we can see for the two data set had score a good data, which is around 99% of 99%, while for the score more than 100, we can see both data score was quite low, but the score for the more than 70 is higher for all the data sets. Now we will discuss about the quality control step. To assess the performance of the methodology had been right by the researcher, there are two key metrics that we focus in this paper. The first one is the semblance-based evaluation and the velocity picking distance to reference. This metric compare manual velocity picking with the automated approach, which is in this paper is the automated approach, providing a valuable insight into the accuracy and reliability of the methodology. The robustness of the methodology is one of its greatest strengths, regardless of the quality, the dataset, or the processing stage. The approach consistently provides accurate and reliable velocity analysis results. In this experiment, the researcher used diverse datasets with a different characteristic, including a dataset with a varied qualities and from different processing stage. The result demonstrated the adaptability and effectiveness of the methodology in the real-world scenarios. The methodology significantly reduced the need of manual annotation, with only a handful of gather requiring manual picking. The efficiency makes the approach both practical and efficient for a various velocity analysis tasks. Next, last but not least, is a conclusion. The conclusion that I can make through this paper is a hybrid regression approach for a velocity analysis using a convolutional neural network has shown a promising result. The combination of automatic initial velocity picking and a supervised find demonstrate high accuracy and efficiency, making it a valuable tool for geoscientists in various applications. So I can say that this automatic picking can provide more advantages to the geophysicists in analyzing the velocity. So the more the better the way of picking the velocities, we will provide the best result for the interpretation for a seismic. There are two recommendations that I would like to recommend for this research paper. The first recommendation that I would like to recommend is the implement data augmentation technique to increase the dataset diversity and prevent overfitting. And second recommendation is gather a diverse and representative dataset of velocity data from a different source and environments. Include example with a varying geological structure, noise level, and resolution. I think that's all from me for this paper review. Thank you.